I'm going to let this be graphing radicals and radical equations. So we'll do about a page and a half of this. Remember, with radicals, you have this as your transformation equation. I'm going to go through a negative in front of there. The negative is a reflection over your x-axis. The A, only positive, because if it was negative, then it'd be a reflection of the x-axis. If there's a number in front of your square root, it's either going to be a vertical stretch or a vertical compression. It's a vertical stretch if your number is bigger than 1. It's a vertical compression if your number is in between 0 and 1, so decimals, fractions, as long as it's not over 1. Underneath the radical, if it's positive, it's going left. If it's negative, it's going right, a little bit opposite of what you think, so be careful with your H. And then the last number outside your radical is going to be up and down. I like to remember this because if you're outside, you can jump up and down. You're inside, flat story, can't go up or down. So let's get to it. 1/3 is a outside my radical, so is between 0 and 1. So it's a vertical compression by 1/3. -4 inside. Negative is right 4. -6. Well, negative is down, positive is up. Exactly like you think. So this is down 6. 2 in front of my radical is a vertical stretch by 2. And then inside plus 5, inside is left 5. On this one, I want you to write the equation for cube root. Oh, I gave you the right answer because I just said cubic, not cube root. But this whole test, this should have had root. Nobody called me out on that one. Surprising. Cube root. So we're going to say y equals the cube root reflected over the x-axis. Reflection over the x-axis is the negative in the front. Then shifted so the turning point is -6, 2. Well, your turning point for cube root, or cubic, it doesn't really matter, is 0, 0. But negative, if ours is at -6, that means it went left 6. +2 means it went up 2. So x is always on the graph. Left is -6 and outside +2. Ah, that's wrong. Left is plus. I know it looks negative, but since my equation's negative, a negative and a negative makes a positive. So when you see a positive, that means I had to have plugged a negative into my equation. So positive, left 5. All right, keep going. Oh, some of the answers are still here. That's a-okay. Remember, with your square root, we have to know the original graph. Your original graph, x, y, 0, 1, 4, and 9. The square root of 0 is 0. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. 0, 0, 1, 1, 4, 2, 9, 3. That is your original graph. That's not what we're graphing on this one, but our original. And then we're going to change colors. We're moving this graph left 2 and up 1. One thing I like to do is just move my x and then plug it in. Plug those numbers in. So if I'm moving these left 2, that means I have to subtract 2 to all of these numbers. So 0 minus 2. 1 minus 2. 4 minus 2. And 9 minus 2 is 7. And then I don't care if it's being vertically stretched, vertically compressed, reflected, moved up or down. It doesn't matter. So once I get my x values, I can just plug those new x values in. So for instance, I'll do 2 of them. So I'm doing -2 plus 2 plus 1. -2 plus 2 is 0 plus 1. So 0 plus 1 is just 1. And you just keep doing this. Now I'm going to do -1. -1 plus 2. Or you can plug this in the calculator. I don't care which one you do. Square root of 1 plus 1. That's 1 plus 1, 2. Or if you would like to, this is a pretty easy transformation. You're going left 2, up 1. So you can just add 1 to all of these y values. Or you can graph it in my graphing calculator, but don't leave graphs blank if you have a graphing calculator. If you need help graphing them, just ask. I will help you. Those are the points we are graphing. Some of you don't even like to use the table if it's this easy. After you graph the original, I'm just moving left 2, up 1. Left 2, up 1. Left 2, up 1. But you really have to remember your original points to do all this. So if you don't know what the original graph looks like, this test is hard. Make sure you know what the original graph looks like. Endpoint. I like start point better, but it says endpoint. That's why they teach it. That's how the book teaches it. But starting on the left, working your way to the right. If you have trouble with domain and range, I really suggest grabbing a box. Let's see if I can mess with this a little bit. Hold on. I need to fill this box in. There it is. Hey, get back here. Fill it in. There we go. Getting a post-it note, paper, whatnot. But you're starting on the left and working your way to the right. And the first point on my purple graph I see is right there. There it is, -2. So it starts at -2. It's a closed dot, so I use a bracket. And then you keep going. The last thing I see on my purple graph is an arrow to the right. So that's a positive infinity. It helps to, with the ignore everything else kind of thing. That is my domain. I'll move it over in a second. My range, start at the bottom, work my way to the top, is at 1. My first y value is at 1. Arrow going up forever, positive infinity. So let me put that in the right spot. -2, positive infinity, negative, +1, positive infinity. Okay. And then again, your endpoint, it's usually 0, 0. It is where it starts. This is my endpoint right here. So this is my endpoint again. So endpoint is a point. So you'll always just use parentheses on this one. -2, 1. Okay. And then your endpoint will always be how it's moved left or right. So if it's vertically stretched or anything, you can ignore that. All right, so far I just have the original graph. The negative in front is going to be reflecting over your x-axis. So to make this point come down, this point come down. The 2 is a vertical stretch by 2, just so you know what's going to happen. It's going to get like longer. So think about stretching a rubber band vertically. And then we're going to move it right 6. That's 3 different transformations. Whoops, over here. But the only thing that's affecting my x values is right or left. So again, I'm just going to do my x values. Right 6, I'm going to add 6 to all these. So I get 6, 7, 10, 15, right? And then it doesn't matter what else is happening. I can just plug these in. As long as you know how it moved left or right, get your new x values, plug them in to get your y values. So -2, square root 6 minus 6. So it's -2 square root 0. That's 0, so that's 0. -6, 0, which makes sense. It didn't go up or down any, so it just moved right 6. -2 square root 7 minus 6. Or just put that whole thing in the calculator. It'd be easier. Square root of 1 is 1, so that'd just be 1 times -2, -2. So positive 7, -2 down here. Makes sense. That's a stretch of 2. I stretched it up more. So now it's just going downwards. With 10, -2 square root 10 minus 6. 10 minus 6 is 4. We know the square root of 4 is 2. And then 2 times -2 is -4. So 10, -4. Down here. If you like to do all the transformations yourself, we're just multiplying all our y values by -2. So if you did 3 times -2, you would get -6. But 15 is off our graph, so we don't even need that. That's why it says 3 points instead of 4. Endpoint is now here. Start point, I like to say. We have 6, 0. It's starting on the left, going to the right. My first, you can move your little post-it note. My first point is at 6. My first x value is at 6. And then I know it's headed down, but we don't care about down on domain. We care that this arrow is headed to the right. Positive infinity. Range is where we care that's headed down. So first thing I get to from the bottom to the top is negative infinity. It's headed down forever, all the way to 6. But that's the x value. We don't care about the x value. We care about the y value, 0. All right. Okay, that's square root. Moving on to cube root. Cube root. Our perfect cubes. Let's go ahead and graph that. Our perfect cube root numbers are -8, -1, 0, 1, and 8. 8's perfect cube because 2 times 2 times 2 gives me 8. Those are the ones we need to memorize. All right, with cube root, you do turning point. And turning point is where you change from concave up. So here this graph is going up, and then it turns to start going down, concave down. So 0, 0 is your turning point. It is the middle of the graph, is the focus point, if you want to call it that. But it's called your turning point. So now we're going to move it. This graph, the 1/2 is going to still be a vertical compression, and the 3 is going to be left 3. Just like I did square roots, all I'm going to do is the x values and then plug it in to find my y values. So if I subtract 3, I get -8, 9, 10, 11, 11, -4, -3, -2, 5. And then plug it in to this equation. So -11, let me work a few of these out so you can see them. Or put it in the calculator, I don't care. -11 plus 3 is -8. The cube root of -8, well, the negative can just come out front. And it's 2 times 2 times 2. So the cube root of -8 is -1. I'm sorry, -2. And then 1/2 of -2 is -1. Whew, a lot of work. Plug in the calculator. Or we're just doing a vertical compression of 1/2. Vertical, so that's all y's. So we're multiplying all of our y's by 1/2. Make my life easy. Just multiply all the y's. Or put it in the calculator. Half, so it's -0.5. I like decimals when I'm graphing. I like fractions for everything else. All right, so it's getting skinnier. So I'm moving it left 3, 1, 2, 3, and it's getting skinnier. So instead of going all the way up, I'm halfway. All the way down, I'm halfway. Or plot the points, that's why we did them, right? And then 5, 1. And -11's off the graph, but at least I'll keep the shape. So I'll keep it. Here's concave up like a cup. Up like a cup, that's concave up. Down like a frown. See, here's our teacup. And here's our frowning face. That's where it's turning. That's called its turning point. We'll do that again in another chapter at the end, our polynomials chapter. But there's our turning point, -3, 0, because it's moved left 3. And then domain and range for cube roots is very easy. It's all numbers. It kind of looks like it's flattening out, but it's not. It goes forever to the left and forever to the right. So I'm going to go ahead and do that for this one, right? Forever to the left, forever to the right. Easy enough. Forever up, forever down. So, okay, so this graph is moving right to, I'm graphing the original. Puka. That's enough. Puka's my puppy, obviously. One of them. There we go. Right 2, down 3. Right is affecting your x values, down is affecting your y's. If you want to do your table, probably the easiest though is just move them. Right 2, down 3. Here it is. Right 2, down 3. Those are those 3 middle points. Right. Right 2, down 3. Right 2, down 3. There it is. There's a graph. Turning point 2, -3. Positive 2, -3. If you wanted to see your table, okay. -8, -1, 0, 1, and 8. 2, 1, 0, -1, negative 2. That's the original. And then our new graph, right 2, add 2 to all these. And then I plug them in. But since there's no real complicated vertical, all we're doing is going down 3. You can also just subtract 3 from all your y's. It's when you do your vertical stretch, vertical compression, that's when I plug them in. I plug in all my x values. That way I don't mess anything up. Okay, so there's graphing, if you didn't remember that from last chapter. And then I'm going to go straight into solving equations. With solving equations, you want to isolate your square root, and then, or cube root, or whatever root it is, and then raise it to the proper power. So isolate the square root. We're getting this by itself first. Some people try to move that 5. You can't. It's stuck under your radical. And then you can raise it to the proper power. But here I'm going to go ahead and stop because a square root can never give me a negative 7. What you're thinking is 49. Square root of 49 is a positive 7. If I put a negative under my square root to try to make it a negative 7, this is imaginary. You can't do a square root of a negative number. This would be 7i. So negative 7 is not possible. So this is no solution. I would stop right here. A square root can never equal a negative number. All right, 3 square root x minus 4 equals 9. Get your square root by itself, so I'm going to divide by 3. 3. Now this is where I said raise it to the proper power. Since this is the square root, I'm going to square both sides. And add over my 4. The square root and the square cancel. I meant to say that. I get 13. Check your answers. So 3 parentheses 13 minus 4 to the 1/2 equals 9. Does this equal 9? Put it in a calculator. All right, when I put it in a calculator, it does equal 9. So 9 equals 9. You know your answer is correct. 13 is my answer. When you go to check your answer, you're just making sure your answer makes sense. Get your cube root by itself. So I can't get rid of that 5 until that cube root symbol comes out. Minus over your 2, I get negative 5. Here I would stop if this was a square root, but we can have the square root of a negative number. I mean the cube root of a negative number. Try this again. The cube root can give you a negative number. Actually, it's the cube root of 125. Cube root of 125 is 5. The cube root of negative 125 is negative 5. So we know everything underneath this radical, cube root, has to equal negative 125. Add over your 5. Divide over by 6. Check your answer. Make sure it makes sense. Don't care about that. Cube root of 6 times negative 20. That's negative 120. Minus 5 is negative 125. Cube root of negative 125 is negative 5. Negative 5 plus 2 does equal negative 3. So, yes, this works. If you have 2 radicals, 2 square roots, 2 cube roots, 2 any of them, get one on the left, one on the right, raise it to the proper power. Here, since they're square roots, we're raising it to the squared, and anything in your radical drops out. X is on one side. Subtract over x, I get x minus 1. Add over your 1, you get 4. X equals 4. When you have x's on each side, you're just plugging them into both sides and making sure they equal. So this is the square root of 7. 8 minus 1 is also the square root of 7. Obviously, that's true. We don't have to put in a calculator. Again, a cube root, we would need to add over the cube root. So we have 1 on each side. If you don't do this, then you have to FOIL. And you don't want to do that. I would not have made you do that. Good college question, but you don't have to do it. So we have the cube root on both sides. So you cube both sides. When I cube the right, everything falls out of your radical. But if I cube the left, the 2 isn't in the radical. I still have to cube that. But the cube root and the cube cancel, and I now have 2 cubed x, which is 8x. Subtract over your 2x, you get 6x. Divide over by 6, you get 3. Check your answer. Go to the original in case you messed up adding it over. So 2 cube root 3 minus 3 cube root. This is a great one to put in the calculator. So if I was going to put this in the calculator, you can just put this whole thing in the calculator and make sure it equals 0. So 0 equals 0. And it does. I'm not going to waste your time to show it in the calculator, but you can try it on your own. This 3 is outside of my cube root. Subtract over 4. 21. Divide over by 3. Cube both sides. 7 times 7 times 7 is 343. Add over 4. 347. Check your answer. Go back and plug it in. 3 parentheses. 347 minus 4 to the 1/3 plus 4 equals 25. And it works. 25 equals 25. This is what I plug into the calculator. I feel like I'm whispering. I gotta talk a little louder. There you go. All right, the last two are the hardest because we actually have to factor. Because when you square both sides here, this square root cancels out with this squared. But on this side, you get x squared. And that is your key that you have to factor. If you get x squared, you will have to factor. So just remember that. I have x squared. Always try to keep x squared positive. Do not take it to the other side because then we haven't even learned that yet. So don't take it to the other side. Keep x squared positive. So I'm going to subtract over my 5x, subtract over my 14. And you want to write it in standard form. And standard form is highest exponent to lowest exponent. So when you're writing these three terms, you're going to put x squared first because that's my highest exponent, and then minus 5x, and then minus 14. This is a trinomial, which means three terms, 1, 2, 3. A is the coefficient of x squared, B is always the number with x, the coefficient of x, and C is always your constant. When you go to factor, you're trying to figure out what multiplies to C, the constant, and adds to B, the coefficient of x. And so far, we've only learned where x squared is 1, so keep that in mind. We will learn when A is bigger than that in a little bit. So we're trying to figure out what multiplies to 14, the constant, negative 14, and adds to negative 5. And 14 multiples of 4. What multiplies to 14 is 1 and 14 and 2 and 7. 3 doesn't go into it, 4 doesn't go into it, 5 doesn't go into it, 6 doesn't go into it. The next number that does go into it is 7. So if I was going to try 7, well, obviously 7 times 2 gives me 14. So once the next number you're trying is over on the right, you know your list is complete. These are the only factors of 14, 1 and 14 and 2 and 7. Since I'm trying to get them to add to negative 5 and multiply to negative 14, one of those has to be negative. And since it's adding to a negative, you want the bigger number to be negative. If it was adding to a positive, you would want the bigger number to be positive. Okay, when we factor, x squared will break into x and x. An x in the front and x in the back. Because x times x gives me x squared. And then this is where your numbers come into play. Minus 7 plus 2. Or you could flip that. Plus 2 minus 7. It does not matter. But negative 7 times 2 gives me my negative 14. And if you wanted to check your middle term, you'd actually have to FOIL it out. X times x is x squared. X times 2 is 2x. Negative 7 times x is negative 7x. Negative 7 times 2 is negative 14. So this is where the negative 5 comes to play and why they have to add to negative 5. But we're not trying to factor because that just give us back, or distribute. I'll get us back right up here. We want to know what they have to be multiply to 0. Well, to multiply to 0, one of these or both of these has to add to 0, be 0. So that's what we're going to do. We're going to set them each equal to 0. Add over the 7, x equals 7, x equals negative 2. Check both answers. If I go back and plug in negative 2, the square root can never equal a negative, so negative 2 doesn't work. It can equal 7, so let's check 7. 5 times 7 is 35. 35 plus 14 is 49. Well, the square root of 49 is 7, so 7 does equal 7, so 7 works. Always check your answers. Usually with factoring, one of them doesn't work. Sometimes it all works, but usually it doesn't. This is the square root, right? That's what 1/2 means. So we're going to square both sides. When I square the right and there's 2 terms there, that means I have to write it in parentheses twice. Okay? And you have to FOIL. You can't just do x squared and 4 squared. You're missing middle terms when you do that. Here, the square root and the square cancel out. So then I distribute. X goes to both of the terms in the other parentheses. 4 goes to both of the terms in the other parentheses. We're multiplying. Combine like terms. Move everything. Oh, we have an x squared, so we're going to have to factor. So move everything to the right because I want to keep x squared positive, or your factoring's harder. All right, well, multiplies to our constant and adds to our coefficient of x, 7. Well, multiplies to 10. 1 and 10, 2 and 5, 3, no, 4, no. My next number is 5, so it's one of these. Obviously, 2 and 5. X minus 2 plus, they're all positive, x plus 5. Set each equal to 0. And then plug them in to check them. If I plug in negative 2 plus 4 is 2. If I plug in negative 2, I need to write it so I can see it. I wrote all over it, didn't I? There we go. Negative 2 plus 6 is 4. And the square root of 4 is 2. So this would say 2 equals 2. So negative 2 works out. If I check negative 5, the square root, negative 5 plus 6 is 1. And negative 5 plus 4 is negative 1. That is not the same. Negative 5 does not work. Okay, next page, next video.